Our third presenters are from Getting Started with Learning Analytics. This is a practitioner track, a full paper, implementing a predictive model validation project at North Carolina State University. We have two speakers today. We have Lou and Sandeep. And Lou, how long, so because the two of you, we were talking about you speaking the whole time.
No, that's so both of us.
When do you want me to? You're still happy with our original time warning?
Yes, I am.
Super. All right, thank you.
Right. So I'll get us started and then hand off to Sandeep. We're gonna dance back and forth a little bit on this. Josh Barron was supposed to be co-presenting with us, but was unable to attend. So Sandeep is going to go through the slides that Josh would have gone through, and then I'll pick it up, and then we'll go back and forth. So if you want to get started. Oh, you're gonna use that? Okay, sure.
I like to move around a little bit. So.
Yeah, he's gonna make it tough for the camera operator.
All right. Okay, so gonna go.
Yep. Moving.
All right. Just a quick introduction on what the project is about, a little bit of background as to where this is all coming from, how we partnered up with North Carolina State University, etc. Ooh, okay. Thanks, Reese. Okay. So a little bit of background on our work, on our prior work. These are again the slides that Josh wanted to cover, so I'll try to run it through really quickly, give you an introduction on the project, and if there are any additional questions, we can definitely dig a lot deeper. So the Open Academic Analytics Initiative was a research grant that was primarily funded by Bill and Melinda Gates Foundation. We got about like $250,000 for over a period of 15 months to build an open source early alert framework, build an open source version of a deployable predictive model which can identify who are the students at risk at various junctures in the semester. So one of the biggest design choices was all of the technology, all of the stack, all of the findings, everything should be shareable so that we can scale it up, right? That was the second main important agenda that we had. We were also looking into how we can take it forward and deploy it at like a bunch of universities, or even better, pool a bunch of universities' data and build predictive models around it so that there's a whole slew of machine learning models that anyone can pick and choose and apply in their setting. So that is a little bit regarding the scaling factors. This was around 2011, 2012. And once the research grant was over, we had a tangible early alert system. And for the effort, we got a couple of awards in 2013, one being Campus Technology Innovators Award, and the other one being Computer World Honors Laureate in the category of emerging technology in education space. So how does this all work, right? Like we are looking into two major data sources. One is the learning management system data. It could be a Sakai, Moodle, Blackboard, Canvas, it can be anything. And then we are also looking into the student information systems data, like Banner, PeopleSoft, Tribal, so all the work we were doing was more data-centric and not like system-centric. So that really helped us open up this particular system, and it could be integrated at the end of the day with any of your platforms that is available in the universities. Because the space is so diverse, we had to do that in order to scale it up ahead. So in terms of learning management systems, we were interested in two kinds of data. One being the event log data. That is, whenever the students interact with the learning management systems, when they're logging in, doing a forum posting, submitting assignments, reading something, it all generates like events that are collected in your databases. So that is a rich data source which helps us map like what the students are doing in the course and how that correlates to success. And the second major data set we were considering was more on the performance level. What are they scoring against each of the gradable criteria that the instructors have set as a part of the course? In terms of student information systems, we were looking into students' demographic details, etc., that they might have provided as a part of their admission process, their prior grades, their aptitude tests, their entry-level grades into the program, right? It's a good balance between like the past data and the present data, which helps us really map like what's the future is gonna look like. That was the whole idea around this. So we took all of this data and married all of this together, cleaned it up, and derived new metrics that can participate in the predictive process, and started building predictive models around it. For this, we used large volumes of historical data. We started at least with around like 3 semesters worth of data, and started really looking for correlations, trends, and patterns, and building that equation that can be applied on the current semester data. So over here, it's a black box in the diagram, but it's not really the black box. It's completely open. You can dig in there and completely understand like the inner workings of the model if you want to. All the documentation is there. So yeah, we developed models using historical data, and later applied it on the current semester. What it gives out is the probability of failure or success of a student, right? That we classify again into high, medium, and low risk categories, and we forward that information to instructors so suitable interventions can be designed and deployed. As a part of our research grant, we explored a couple of intervention strategies, one being just letting the student know that they are at risk, and the other one, it was more like we provide additional support material so that they can make use of that, and we wanted to see if that had a different effect in terms of interventions. Next slide. So yeah, the research design on the intervention side, we partnered up with a couple of community colleges and historically black colleges and universities which have a significant retention problem. At Marist, I should say, we are at about like 90% in terms of student retention, but in the colleges we were working with, it was on the opposite end of the spectrum. So there was a lot of variability in terms of the institutional profiles, right? So we selected courses across all of these institutions. We took a few basic courses like Math 101, Biology, etc., where one instructor was teaching 3 sections of the same course. One, we tagged it as control group. 2 of them were the intervention strategies I talked about. Later, we rolled out an early alert report to them at 25% into a semester, 50% into a semester, 75% into a semester. So it gives more time for the instructor as well as the student to work with them and to impact the performances of the student. So these are the institutional profiles. You can see how diverse they are. Marist is a 4-year private liberal arts institution. There are like a couple of community colleges. The enrollment population is different. One thing I want to bring to notice is this one, where I'm talking about the retention rates, right? Like this is something that is reported by all institutions in America. They reported for like 150% of the normal time of the program. If it is a 4-year program, then they report what's the retention rates at 6 years. And If it is a 2-year program, it's going to be 3 years. So you can see it's on the opposite end of the spectrum, one being at 4%. That was shocking, actually. I had to go back and check if I'm reporting stuff correctly. Yeah. So here are some of the results of how our models worked, right? At Marist, I should say, when we built the predictive models, it was around 86% accurate in terms of identifying at-risk students. In terms of the 3 runs we did in each of the institutions, that is your AAR1, it's Academic Early Alert Report 1. It was done at 25%, 50%, 75%. And we started tracking at the end of the semester how accurate were our models in terms of identifying the at-risk students. When you see the accuracy ranges, it starts from 65%, and this is a model we built using historical data from Marist College, and we were not yet tapping into the institutional data yet, right? So yeah, it starts at about like 65% and progressively increases with more data availability to 75%. The most important metric is recall, because it is kind of the accuracy within the at-risk population of the students. So you're selecting a subpopulation and checking for how we are performing in that particular subpopulation. What this really tells us is the models, the data points we are looking at, the processes, it's portable, right? You can replicate this design in your institutions, bring in your data, and you'll be able to get at least a good baseline of 65 to 70%. Obviously, each institution is different. They have more data collection mechanisms, some different than other. You can, over time, enrich the data sets that you're working with, expand your data points so that the models become even more accurate. This kind of fits into our equation of building common predictive models for a bunch of institutions, and it really helps us in terms of learning at scale and making that impact in terms of overall retention rates across the country. So we also analyzed like how did our interventions perform. Although it was not like the major focus of the grant, we wanted this to be a part of it, mainly because we wanted to know what the action piece looks like, right? Like at the end of the day, you identify a student, but what's being done about it, is it really impacting anything? Ooh, so, sorry. Yeah. So if you see, we found some statistically significant results in terms of like improvements in course average grades, and as well as content mastery, right? They were performing better in terms of the intervention groups, the awareness, and OASE is like open academic support environment. That is the additional materials we were giving to the students. And then the control group. So we started seeing some significant jumps in terms of like how the students are really making use of this, and it's being helpful. So that was a lot of research work we did, and I ran through a few slides just to give an overview. We're going to talk more about NC State now. If you want to learn more about the research, we have the paper over here. It's a 40-page long paper that we published with Journal for Learning Analytics. So please do check it out, and would be happy to answer any questions.
Thanks, Sandeep. I'm Mike. So before I start, I just want to say we gave a similar version of this talk at EDUCAUSE last fall, and there were a lot more speakers involved. So I'm sort of an aggregator. Everybody couldn't come to Edinburgh. I drew the long straw, and so a lot of these are like Sandeep did Josh's slides. I'm doing some that were my boss's slides and some that were mine, and so on. The other thing I wanted to say is that my boss is sort of an insufferable tyrant, and I hope she's not watching right now. Hi. But she really would like photographs of this to document it. If you're tweeting type people and don't mind taking a picture while I'm talking and hashtag it LAK'16, maybe I won't get fired. I don't I don't know. Maybe I'll get a raise even. No, I'm from North Carolina. We don't do raises. Sorry. Yeah. So just very briefly, I saw a version of what Sandeep just did that Josh gave like 4 years ago, and Josh and I started talking about the possibilities. We like very much that this is an open model and not a black box, even though it looked like one on the slide. And so we started a dialogue, and it took several years for me to spread the word around my campus and other people to chime in. We socialized an idea where, hey, this learning analytics thing might be good for student success. It turns out this may be similar at your university. Student success is actually a priority for us. It's number one, as a matter of fact. How about that? So we got some buy-in. People thought this was an interesting idea. I got funding. We started working with Josh. Meanwhile, we started talking about the notion on campus, right? So we brought together a lot of people. I'm in a division that runs learning technology at scale for the university. We also have the registrar. We have the student affairs people. We have a whole division that does nothing but statistics for the university as well. All little different offices. Some might say fiefdoms, some might not, but everyone was sort of thinking differently. I won't promise you that we're all thinking the same right now, but we started having this group of people come together, the occasional lunch and learn. Josh and Sandeep came down and did a presentation, again, similar. We had people from EAB come in and talk. We had a couple other vendors come in and talk. And again, I got money for phase one, and I've actually gotten money for phase two. We'll talk a little bit about phase two if we have time at the end. So phase one actually completed at the end of last fiscal year, which was last June-ish, almost a year ago. And the goal was to take some of our historical data, sort of munge it a bit, give it to Sandeep. Munge it, sanitize it, then give it to Sandeep, let him do some preliminary work like they did with Marist and the other three schools to see if, the model kind of worked for us, or in the same way, or maybe we're very, very different. We didn't know at that point. So we did that. We had to get, clearance from a bunch of people to send all of this data, even though it was sanitized, off campus, because there are data people who worry about things like that. We got all the approvals. We did a small sample size. One of my guys, Jeff Webster, did a lot of mapping, right? Because this initial project was designed with Sakai in mind as the LMS. And I'm not sure what SIS you guys used.
We use Banner.
Yeah, so they use Banner. We're a people shop and Moodle campus, so clearly the fields are all different, and we had to do some of this. It was magic, and then we sent it to Sandeep. It was a multi-step process. It was manual. He does, runs this, runs that, runs the other thing, and I'll let you chime in about the results.
Sure, just quickly jumping in. Phase one was really experimental stage. We wanted to see how the models we built at Marist College can be applicable, will it be applicable, what the accuracies look like. So we took like a sample of historical data that Lou's team forwarded to us and did some number crunching on it and fed it into the model. At the end of the day, when we built a whole slew of models and we wanted to be a little more thorough as to which models really work in their setting. We started to see accuracies at around like 75% to 77%, And I should point to the recall factors out there, which is the model's accuracy in capturing the at-risk population. It was about 88%. I mean, even at Marist, it was like 86%. So yeah, that was kind of kind of finding. And also, that meant like, oh, okay, we need to dig a lot into this and get to the bottom of it, right? Like, there was another factor, which was like we were raising a lot of false alarms in the process, as in, just to give you an analogy, we are casting a larger net to capture all the fish. That means, you're looking for a particular type of fish, but you're also capturing others as a part of this. Sure. So a lot of false alarms, right? In the phase 2 that Lou's going to talk about, we wanted to balance this out, right? Like using their data.
Right. So I will say, Sandeep was much more concerned about the false positives than I was. My thought being, I would rather identify a few extra people that might get some remediation than miss some. Right, so in my mind, I'm much happier with false positives than false negatives. So
yeah, and also one of the reasons for raising so many false alarms was also because within our model calibrations, we kind of boosted the threshold in terms of like the gradings, right? Like they had to score a grade of B and above to demonstrate good understanding, or else we were kind of classifying them as at risk, etc. So you can clear the course, with a grade C, or if you're an undergrad, even with a grade D. But yeah, that was one of the factors.
All right. So again, that work finished last summer, and since then we've started on phase 2, and it's almost concluded because it's time for the final bill very soon. The way our billing structure works. But just to give you an idea, so the goal with phase 2 was to make it more enterprisey, right? So we didn't have to have, run this little thing, then move it over here, run this little thing, and run this little thing, and so on, which Sandeep did in phase 1. We wanted it to be sort of a one-button push. The other thing is that he was using relational database tools in the first phase, so we've paid Sandeep and company at Marist and a company called Unicon to move it to big data tools, Hadoop primarily, and then there's a bunch of little bits of that all have silly names. But again, our goal is to be able to run this for the entire student, every student in every course, any day. I won't say every day, but any day we want of a given semester, click a button. Thank you. And make it happen. And again, hopefully early enough for an intervention, right? So I remember we had these lunch and learns and brought all these people together. I was hoping that I would be able to say we got it all figured out. We know what we're going to do with the data once we have the data to hand off to somebody. We don't. It's not yet clear to me how the data will be used at this point. The folks who are sort of, that's their bailiwick, I don't know that they've decided yet. There's a couple possibilities. Certainly they could give them to the academic advisors. We could expose it to the faculty. There are choices. Nothing has been determined yet. I think we'll hopefully see some traction on that next fiscal year. I did want to talk about a couple of things that we are trying to figure out, right? So one is, how early can we make a prediction where that it's valid and it can make a difference? Because there's no point in making a solid prediction at the 75% mark like they did for the research project. It's too late, right? I want to hit it 2-3 weeks in tops so that we can do something to save, swoop in and save the day, as it were. And the second thing is that right now we're using a single model. Sandeep has surmised that maybe we would be better off with multiple models, one for engineering students, one for humanities students, one for design students, and so on and such. Certainly multiple models will be better. It's not clear to me yet how much better, what the incremental benefit is compared with the incremental cost of maintenance of all of those models, right? So Sandeep, as part of wrapping this up, is making us some cohort-based models and hopefully keeping track of what it costs. And then to answer both of these questions, We have, starting last fall and through this spring as well, every single day we have snapshotted our data. Okay, so I can go back to day 3 of last fall and pretend it's that day, run a single model and run it against cohort models and actually see if the predictive quality is, a little bit better or a lot better. Or I could run it on day 3, day 4, day 5, day 17, whatever, and see if there's a sweet spot, if you will, right, where the model prediction gets a lot better, and then we say, that's the time when we want to run it consistently. So we've got a huge disk in the back room that we're just storing all of these snapshots every single day, and we hope maybe next year to come back and tell you a little more about the answers to those questions. I think, she just held up the 1 minute marker. So I think that's everything. I think we're oh, you want to talk a little bit about our results very quickly? So
last week, we kind of got the preliminary findings from phase 2 work. As Lou was mentioning, there was a lot going on. We were scaling up this architecture so that we were using systems like Hadoop and Spark, so that for the daily snapshots and everything that they're planning to run, it's a lot more conducive. So the entire platform was re-architected. That's running, all good, single button push. And also the time frame, Lou's requirement was let's do this in about in about like one day, right? Like we did even better. We did it in 1 hour. So they can run the snapshots against and
preliminarily we're still at about 80%.
Yeah.
So
we're still at about 82%.
Still looking very promising.
Yep.
I want to make sure we leave time
sure.
for questions. So.
Thank you very much. Yeah, we have time for a couple of questions. Alan, I'll come to you after me. I haven't asked a question yet. Having done a lot of, I am concerned with the false positives. I'm concerned with 25% of a false positive, knowing that students and knowing that we collected a lot of information and comments from students, and students get really irritated when they're contacted, and they're contacted multiple times and there's nothing wrong. And what happens is you turn a false positive into a negative. You've actually created a sense that, oh my God, they think something is wrong. I thought I was doing okay, but now I'm not. Oh my God. So the false positives is a concern.
Yes, definitely. As a part of phase 2 work, we dropped it down to 17 to 18%. And with more data points being available, we are working with the specification from the research grant we had, and they have richer data sets, which we are planning to tap into to reduce that false positives. So, yeah.
Great. Yeah, we've got one question.
A newbie question. Are you doing ensembles of algorithms? Because you're talking about cohorts. Wouldn't ensembles be more robust?
Yeah, we are experimenting with ensemble techniques. So different cohorts, right? Like they have their own models. I mean, they're all micro models. At the end of the day, all of them get together to give you the final prediction. So that is something we are considering. Again, that is going to be the next phase of work that we are doing. So yeah, more findings in next lab.
So you're relying on data from the learning management system as part of what goes into the model. And I'm just curious how you're ensuring that your faculty on your campus are actually all using the learning management system in an equal and cohesive way so that you actually have data to feed into your early alert, or are you just satisfied with only hitting? I know at my university, maybe 50% of the classes are actually intensively using the learning management system in a way that this would work.
Right. So the short answer to your question is we're not, and we couldn't, the way our faculty and academic freedom work. But I will say that, as I understand it, the model is geared to be relative to the class. So if a class is using the technology heavily, then the students are sort of compared with their peers who are using it heavily. If they're using the technology more lightly, they're compared with their peers using it more lightly. In fact, when we look at gradebook columns, we don't even necessarily know how much they're worth towards the final grade, because a lot of our faculty don't set the formulas up until the bitter end, right? It's just the way things are on our campus. The good news, and I think this is good news for two reasons. One, the good news is that most of the predictive power is still coming from the static data, from the demo data that comes out of SIS. That's good because that's consistent, right, across the courses, right? And the second reason that it's good is that it's just as good at the beginning of the semester as it is 3/4 of the way in. So since most of that predictive power is coming from that, the early predictions are still pretty darn good. If that makes sense.
Thank you. Actually, we've run out of time for the session, so thank you very much. I'd like to thank all three speakers, and thank you for your questions. Thank you.